So on the subject of graphing polar curves, I wanted to talk about some of the algebra that is associated with polar graphs. So some common phrases that we'll see as far as these are concerned would be something like determine where a graph intersects the pole. Now, if we say determine where a graph intersects the pole, what we're saying is set r equal to 0 and solve for your other variable, in this case, theta. Another possibility would be determine points of intersection. Of polar curves. Generally, that would involve setting two things equal to each other. And solve for theta. Now there is the possibility, though, that two things could also intersect at the pole for two wildly different values of theta, so please be aware that that's a possibility as well. So as an example, I would like to determine where, let's do r equals the cosine of 2 theta hits the pole. Now, we went over the graph of r equals the cosine of 2 theta in another video in this playlist. Now, determine where it hits the pole means that we are going to set r equal to 0 and then solve for theta. So setting r equal to 0 means that we'll have that the cosine of 2 theta is equal to 0. Now the cosine is equal to 0 every time we're at pi over 2, or generally any odd multiple of pi over 2. So what we're saying is that 2 theta would be equal to pi over 2 plus some multiple of pi. So this is where k is any integer. To finish solving for theta, we divide both sides by 2. We'll get pi over 4 plus k pi over 2. Now, as we start plugging in values of k, we're going to find that there are going to be 4 valid values of k that are going to produce something that is within the given interval. So at k equals 0, this will be theta is equal to pi over 4. For k equals 1, this will be pi over 4 plus 1 pi over 2. Getting a common denominator and adding together will be 3 pi over 4. Adding an additional pi over 2 would be 5 pi over 4. And adding an additional pi over 2 after that would give us 7 pi over 4. Meaning that when we created this polar graph, there are going to be angles where this thing is responsible for coming back to the pole to intersect. So putting together the graph will look something like this. Definitely not drawn perfectly because, well, I was a math major, not an art major, but hopefully that makes it kind of clear as to how we're creating the 4 petals of this rose. Next up, let's try out the following problem. Determine points of intersection between, let's do r equals 3 and r equals 6 times the cosine of pi. Now do keep in mind that when we say r is equal to 3, that technically r equals negative 3 would be the same graph. It would just be the opposite side. So with that in mind, we are going to set 6 times the cosine of theta equal to 3, and we're also going to set it equal to negative 3, and see what we get. Now in the first case, we'd be saying that the cosine of theta is equal to 1/2. And all of the angles on the unit circle where cosine of theta is 1/2 would be pi over 3 and 5 pi over 3. In the second case, 6 times the cosine of theta being -3, we're saying that the cosine of theta is equal to -1/2. And all of the places on the unit circle where that happens would be 2 pi over 3 and 4 pi over 3. However, if you consider what these two graphs actually look like, 6 times the cosine of theta, or r equals 6 times the cosine of theta, is a circle extending to the right side of the pole. R equals 3 is a circle of radius 3 centered at the pole. Those are supposed to have the same radius, and it is not even close. Oopsie poopsie. I see that there are only 2 points of intersection despite the fact that we've indicated that there are 4 angles. Well, fact of the matter is, this angle right here in quadrant 1, this one's pi over 3, and this angle right here in quadrant 4, well, that's 5 pi over 3. In both of these cases, we said that that's where r is going to be a positive value. The corresponding angles in quadrant 2, for 2 pi over 3, is actually where r is negative. We said at 2 pi over 3 our value is negative, and so it draws us back into quadrant 4 in the same direction as 5 pi over 3. And for 4 pi over 3, that's a quadrant 3 angle. But once again, for the angle of 4 pi over 3, we're actually going to be moving in the negative direction, and that's going to take us to this point right here. So despite the fact that we got 4 different angles here, there are really just the 2 points of intersection between these two circles.